Hey everyone, welcome to This Explainer. I am absolutely thrilled to take you on this journey today. We're going to explore the massive, wildly fast-moving AI ecosystem. We'll start deep in the computer science theories, the real nuts and bolts that make generative AI tick, and then travel all the way down to its real-world impact. We're talking everything from college dorm rooms to high-stakes modern hospitals. We've got a ton of incredible ground to cover today, so let's just dive right in. Okay, here's our roadmap for today. First, demystifying generative AI. Second, the AI-powered student. Third, transforming modern healthcare. And finally, ethics, challenges, and governance. So part one, demystifying generative AI and that major shift from perception to creation. To really get a grip on where we are right now, we have to talk about a massive paradigm shift. I mean, this has completely rewritten the rules of AI over the last decade. See, for years, traditional AI was pretty much all about perception, classification, and prediction. It looked at data and basically asked, okay, what is this? It was purely analytical. But modern generative AI, or GenAI, totally flips the script. It's focused on creation. Instead of asking, what is this? It asks, what can be made? It's taking these models from just categorizing data to actually dreaming up new original content that honestly is practically indistinguishable from something a human would make. To truly grasp how machines became these creators, we're using this comprehensive survey by George Sebastian as our compass today. This academic foundation is super important because it traces our modern AI era directly back to early statistical methods and those big deep learning breakthroughs. It proves that, hey, this isn't just magic, right? It's literally decades of math culminating in what we see today. Now, today's AI tools are powered by some very distinct neural architectures. Think of them like different tools in a developer's toolkit, each with its own quirks and trade-offs. You've got VAEs, which learn these smooth probabilistic spaces, but, they can sometimes give you blurry outputs. Then there are GANs. They play this wild, high-speed adversarial game against each other to get incredibly sharp images, but they can be notoriously unstable to train. Then you have your autoregressive models. These predict sequentially, kind of like guessing the very next word in a sentence. The quality is fantastic, but man, it can be slow. And then transformers. These are the absolute heavyweights when it comes to scaling and long-range context using self-attention, though they are computationally very expensive. And finally, diffusion models. These create stunning, high-fidelity images by slowly reversing Gaussian noise. It's a fascinating process, but again, a bit of a slow, iterative crawl. So the really crucial point here is understanding this shift toward what we call foundation models. Instead of building thousands of narrow, hyper-specific models for every little thing, developers are now training a single, massive model on broad data at a tremendous scale. What does this do? Well, it amortizes those mind-boggling upfront training costs and allows that one model to be adapted to a huge range of downstream tasks. This is exactly what gives us the emergent multimodal capabilities we see today, where a single system can handle text, images, and code all at the same time. All right, moving on to part two, the AI-powered student and how this is augmenting the college experience. Let's zoom into our first micro-level environment to see how this plays out in reality. Picture a student's daily workflow in the 2026 academic landscape. They might use ChatGPT as a late-night brainstorming and coding co-pilot. Meanwhile, Google Gemini is handling real-time research right there in their workspace. Then you've got Perplexity AI acting as this evolved search engine, handing them direct answers with actual reliable citations. Grammarly is quietly polishing the tone of their essays, and when it's presentation time, Canva AI and Gamma step in to automatically build these beautiful slide decks. They even have Notion AI organizing the total chaos of their schedules, and Google's Notebook LM instantly chewing through dense research documents to spit out customized study guides. These aren't just flashy gadgets anymore. They're smart assistants, literally saving students hours of routine busy work. I mean, think about it. Traditional studying meant hours of disjointed research, frantic manual note-taking, and formatting presentations completely from scratch. AI-assisted studying takes all that friction and just replaces it with instant summaries and automated design. But, and this is a really vital takeaway, we are absolutely not replacing the student's critical thinking here. AI is meant to be used ethically to augment their workflow. By drastically cutting down the time they spend on formatting and just gathering initial data, students can actually dedicate way more time to concept mastery and deep critical analysis. It's a total game changer. Let's shift gears to part three, transforming modern healthcare. This is high-stakes AI augmentation. So let's zoom in on a much, much higher stakes environment, the hospital. This is where AI moves rapidly from the computer science lab straight into life or death practical application. Take this number, for example, 17.6%. That represents a massive leap in diagnostic capability. There was this huge German trial involving over 460,000 mammograms, and they found that simply adding a generative AI triage tool to standard breast cancer screening bumped up early cancer detection by 17.6%. And the craziest part? It achieved this without increasing the recall burden, meaning zero extra false positives for patients. Incredible! Next up, 15,791. We all know clinical documentation demands have been just eating away at clinician time and morale for years. Well, this number represents the massive total of hours reclaimed in a single year at Kaiser Permanente. How? Just by introducing ambient large language model scribes to handle their clinical documentation. To put that into perspective, that is the equivalent of giving roughly 1,794 clinician days right back to direct patient care. $41.5 million. Obviously, healthcare isn't just about direct patient care. It's also a colossal administrative machine. On the administrative side of things, an AI system called DataProbe scanned billing records and managed to identify $41.5 million in false Medicare claims. And it did this in just a matter of months. That strips out waste and immediately frees up essential resources that can be used elsewhere. And to sum up the financial stewardship that is really driving this rapid adoption, look at this benchmark return on investment. $3.20. Across enterprise healthcare AI projects, hospitals are seeing $3.20 returned for every single dollar they spend. And they're usually seeing that return within just 12 to 14 months of implementation. But look, bringing these tools into a complex hospital setting isn't as simple as just, downloading an app. Healthcare leaders have to follow a strict, four-step adoption roadmap to safely bridge that gap between technical promise and actual accountable value. First, they create urgency around a local pain point, like documenting exactly how much time doctors are losing to typing. Second, they build a multidisciplinary coalition, getting clinicians and data scientists in the same room to share ownership. Third, they pilot test the AI in high-signal but low-risk settings, iterating on it weekly. And finally, step 4, they scale the technology by institutionalizing the governance, cybersecurity, and continuous bias audits. You have to do it right. Which brings us to our final section, Part 4, Ethics, Challenges, and Governance, the societal implications of scaling AI. All right, let's zoom back out to the macro level. This rapid, explosive advancement brings a really complex web of largely unresolved societal challenges. We are simultaneously facing the very real threat of deepfake disinformation, navigating these massive intellectual property disputes because models are training on scraped internet data, and fighting to ensure these systems don't just amplify algorithmic bias. And that's all while we're trying to weigh the economic impacts of labor displacement, not to mention the massive, massive carbon footprint required to train these foundation models in the first place. And on top of all that, despite the truly amazing capabilities we've seen from dorm rooms to operating rooms, reliability is still a huge hurdle. We call this the hallucination barrier. Large language models can, and absolutely do, generate factually incorrect or just plain nonsensical information. This persistent weakness is exactly what blocks autonomous adoption in high-stakes domains like medicine and law. It highlights perfectly why, at least for now, AI has to remain a co-pilot. It requires continuous human oversight, rigorous audits, and vastly better safety alignment. So that brings us to our conclusion. As we stand right here on the edge of this technological frontier, looking at both the incredible potential for human augmentation and some pretty severe systemic risks, I want to leave you with a provocative thought to ponder. How can we deliberately steer generative AI toward human flourishing while making absolutely sure we respect and protect our shared social fabric? Think about it. Anyway, thank you so much for joining me on this explainer today. Keep learning, keep questioning, and I will see you next time.